In a soundless expanse far beyond Pluto's reach, movement stirs. A minuscule pinpoint of radiance is journeying inward from the deep, starless gulf between the stars. Plainly, it is a stranger to our solar system. Recently, astronomers have come to a remarkable realization. A traveler from a distant star system has entered our domain, marking only the third such discovery since the enigmatic Oumuamua astonished the globe in 2017. During the middle of 2025, a telescope stationed in Chile caught sight of this enigmatic object, charting an unconventional course. At first, it was merely a dim flicker in the asteroid terrestrial impact last alert system, known as ATLAS, which continuously scans the heavens for anything out of the ordinary. The find unleashed a surge of excitement, mingled with bewilderment. Was it a comet, perhaps an asteroid? And what could explain its peculiar path? The first detection occurred on the 1st of July, 2025, by the ATLAS Survey Telescope in Rio Hurtado, Chile. The object was initially tagged with the obscure code A11P3Z. It was not long before astronomers noticed its route did not fit any known orbit within our solar system. Just one day later, the International Astronomical Union confirmed suspicions that had already begun to circulate. This was, indeed, an interstellar visitor, the third of its kind ever observed. It was officially christened 3I-Atlas, where the I signifies interstellar origin. Imagine for a moment a chunk of ancient rock and ice, once part of another star's domain, now drifting through our own celestial neighborhood. For astronomers, the discovery was a moment of pure revelation. For the wider public, however, it sparked a sense of unease. Should we be concerned by this alien comet? Thankfully, the answer is reassuring. There is no cause for alarm. From the outset, experts determined that 3-Atlas poses no direct danger to Earth. Its trajectory will never bring it close enough to threaten us. Even at its nearest approach, it will remain over 150 million miles away, roughly 1 6/10 astronomical units, or 1 6 times farther than the distance from Earth to the Sun. In fact, this interstellar guest will not come closer than the orbit of Mars, which means there is no risk of collision, only a rare opportunity to expand our knowledge. Larry Deneau, a scientist integral to the ATLAS project, acknowledged that our understanding of this object is still quite limited. For scientists, admitting what we do not know is both humbling and exhilarating, for it signals the arrival of something genuinely novel. Here is what has been established so far. 3I-Atlas measures up to 12 miles across, a colossal cosmic iceberg by any definition. At the time it was first detected, it lay about 4 1/2 astronomical units from the Sun, or 4 1/2 times farther than Earth's distance from our star. Now it is streaking through space at a breathtaking pace of nearly 40 miles each second, which amounts to more than 140,000 miles per hour relative to the Sun. No comet native to our solar system travels at such extraordinary speeds on its own, making it clear that this object was cast out from a distant place. The official bulletin from the Minor Planet Center underscored its uniqueness. They noted subtle comet-like behavior, including a faint coma and a slender tail only 3 arcseconds long. In other words, 3I-Atlas is not simply a dormant rock, it is already displaying signs of activity, much like a comet awakening as it draws nearer to the Sun's heat. A hazy shroud of gas and dust, called a coma, now surrounds the comet's nucleus, with even a delicate dust tail trailing behind. The object has begun to sublimate. Its frozen gases are warming and turning directly into vapor, creating a luminous halo and a stream of particles in its wake. All these observations took place when 3-Atlas was still extremely distant and dim, shining at around 18th magnitude, far too faint to be visible without a sizable telescope. Yet the very fact that astronomers detected it at all highlights the advances of modern skywatching. After Atlas raised the alarm, telescopes in Hawaii and Australia joined the worldwide effort, tracking the object and mapping its path. Amateur astronomers scoured archival images and uncovered pre-discovery photos buried in data from mid-June of 2025. These early sightings allowed experts to refine its trajectory and confirm its interstellar origin. By July of 2025, the verdict was clear. Humanity was on the verge of witnessing the approach of an interstellar comet, the third such event ever recorded. Naturally, the next question on everyone's mind was how this celestial wanderer compares with those that came before. To grasp just how extraordinary 3I Atlas is, let us first revisit its two forerunners. The earliest of these was detected towards the end of 2017 and was bestowed with the Hawaiian name Oumuamua, meaning a messenger or scout from a distant place. The second, found in 2019, was dubbed 2I Borisov, named in honor of the amateur stargazer who made the discovery. These two celestial visitors stood in stark contrast to one another, and 3I Atlas now brings a fresh and unexpected element to their unfolding saga. Oumuamua baffled astronomers from the start. Measuring roughly 100 yards in length, it was a slender, cigar-shaped enigma that showed no visible coma or tail like the comets with which we are familiar. As it drifted away, it even exhibited a subtle yet noticeable acceleration that could not be explained by gravity alone. This odd deviation might have resulted from escaping gases, or perhaps something far stranger. Such peculiarities fueled rampant speculation, though the majority of scientists favor a natural origin, perhaps as a shard from an icy world much like Pluto. Ultimately, Oumuamua departed with more mysteries than solutions. By comparison, 2I Borisov felt much more recognizable. Upon its arrival in 2019, it behaved like a typical comet from our own solar neighborhood, displaying a luminous coma of gas and a trailing tail. Spectroscopic analysis revealed its makeup to be akin to other comets, featuring water vapor and molecules built on carbon. If it were not for its unbound hyperbolic path, it could easily have passed for a native of our system. Now, with 3I Atlas, the central question arises: does this latest interstellar visitor take after Borisov or Oumuamua? Early findings indicate that Atlas bears a closer resemblance to Borisov. Though faint and racing across the sky, it sports a characteristic hazy coma, a sign that ice is present and vaporizing. This evidence points to Atlas being an icy, comet-like object, not a solid chunk of rock. Crucially, it has not displayed any overtly bizarre activity thus far. In summary, there is no indication of alien technology, merely a fascinating comet hailing from beyond our star. Yet there is something that sets this object apart: its sheer size. The newcomer appears to surpass both Oumuamua and Borisov together in scale. Based on its brightness at the moment it was first observed, astronomers estimate it may measure between 9 and 12 miles across. This is considerably greater than Borisov, which spanned about 0.6 to 1 2/10 miles wide, and far more massive than the diminutive Oumuamua. Should these estimates prove true, Atlas could possess a far greater mass, offering scientists a more abundant supply of material to study as it emits gas and dust. Another key difference lies in the angle and direction of its trajectory. Oumuamua approached from the plane of our solar system, approximately aligned with the star Vega. Borisov originated from a completely separate region of the heavens, namely the direction of Cassiopeia. This latest traveler appears to be arriving from the constellation Sagittarius, pointing roughly toward the heart of our galaxy. In galactic parlance, Marshall Eubanks, the physicist monitoring the object, suggests that Atlas most likely emerged from the thin disk of the Milky Way. This thin disk is a broad, flattened expanse where the majority of stars, including our Sun, orbit the galactic center. This implies the object may have formed around a star somewhere within the Milky Way's sprawling disk. Naturally, we cannot pinpoint the exact birthplace of that star. To do so, we would have to retrace the comet's journey and compensate for millions of years of galactic motion, a task well beyond our present abilities. Still, the fact that it likely hails from the inner galaxy hints that it may be made from the same kinds of materials as the comets we know locally. It is also worth highlighting that all of these interstellar wanderers, no matter their differences, share a crucial trait. None are bound to our sun. Each follows a hyperbolic, open-ended orbit. They sweep into our solar system, arc around the sun once, and then speed back into the vastness of interstellar space, never to return. In fact, it was precisely this hyperbolic path that revealed to astronomers that Atlas was not native to our solar system. Initial computations revealed an orbital eccentricity close to 6, vastly surpassing the value of 1 that marks the threshold for gravitationally bound paths. This finding means the object is not tethered to our sun, but instead hails from somewhere far beyond the boundaries of our solar system. Yet, curiosity lingers about the odyssey this object has experienced before its arrival here. Was it once a comet gracefully circling a remote star, following a tranquil path much like Halley's Comet does around our own sun? Perhaps a near miss with a colossal planet in its home system sent it careening off course, casting it out into the empty stretches between stars. For centuries, it wandered the vast darkness, until fate guided it into the vicinity of our star. Though its full history may remain a mystery, as the third interstellar object approaches, astronomers are seizing every opportunity to uncover its secrets. Now, midway through the year 2025, the object known as 3I Atlas draws nearer, capturing the attention of skywatchers across the globe. Let us delve deeper into its trajectory and current status. What can we determine about its path and its activities on this cosmic journey? The orbit of Atlas is extremely hyperbolic, signifying it is a fleeting visitor. It entered from interstellar space and, after its close brush with the sun, will head back out into the cosmic void. More specifically, projections indicate it will reach its nearest approach to the sun, known as perihelion, near the end of October in the year 2025. For Atlas, the perihelion distance measures about 1 4/10 astronomical units, which equates to roughly 130 million miles from our star. This places it just within Mars's orbital path. Additionally, along its route, the object will pass relatively near Mars itself. In October, it is predicted to come within 4/10 astronomical units of Mars, or about 37 million miles from the red planet. While not an extremely close encounter, this is near enough that orbiting spacecraft might observe it. For instance, NASA's Mars Reconnaissance Orbiter could potentially snap a picture as 3I Atlas passes by. Researchers are currently assessing whether cameras stationed on or around Mars could document this event. As mentioned earlier, this visitor is traveling at a remarkable speed. Even when far from the sun, its velocity relative to the sun was about 37 miles per second, and as it plunges inward, gravity continues to accelerate it. By the time Atlas sweeps through perihelion, it is expected to be moving faster than 150,000 miles per hour. For comparison, this is approximately double the orbital speed of Earth itself. Once it slingshots around the sun, Atlas will gain sufficient velocity to break free from the sun's gravitational pull entirely. Indeed, by April of 2026, as it returns to interplanetary space, its speed relative to Earth could approach 55 miles per second, making it the fastest natural object ever witnessed in our solar system. In essence, we are observing one of the swiftest travelers our cosmic neighborhood has ever encountered. This third interstellar visitor has already earned its classification as an active comet. Early sightings of a faint coma and a short tail have since been corroborated. As it journeys through the outer reaches of the solar system, solar warmth begins to vaporize the ice on its surface. This process, called sublimation, releases gases and dust, forming a nebulous coma around the nucleus and a tail that grows as it is pushed away by solar wind and light. By the middle of the year 2025, the coma remains subtle. The comet's apparent brightness is around 18th magnitude, which is much too faint for unaided vision. However, large amateur telescopes are able to detect it. Enthusiasts equipped with sensitive CCD cameras and lengthy exposures have started to record it as a faint, drifting blur against the backdrop of stars. Week by week, as more of its ice vaporizes and it edges closer, the comet is expected to brighten. Forecasts suggest that by August or September of 2025, it could reach 15th or 16th magnitude, possibly even a bit brighter. Still, this remains too dim for the naked eye. For comparison, the faintest stars visible to the unaided eye on a pitch-black night are about 6th magnitude. Yet a comet shining at 15th or 16th magnitude is within reach for countless amateur astronomers armed with telescopes and advanced cameras. Nick James from the British Astronomical Association remarked that Atlas should remain visible to enthusiasts using basic equipment for roughly the next 12 months. Still, it is wise to keep expectations grounded. Comets have a reputation for defying predictions. Experts suspect that since 3I Atlas originated around a different sun, it might break the familiar patterns of brightness we are used to. It could suddenly become much brighter than anticipated, or it might dim unexpectedly if its surface crust prevents gas from escaping. What then is the true nature of this third interstellar object? That question strikes at the heart of our curiosity. If we manage to capture spectra from its coma, splitting its glow into a rainbow to reveal unique chemical signatures, we can compare its makeup to comets that call our solar system home. When 2I Borisalt was under scrutiny, scientists detected well-known gases such as cyanide, diatomic carbon, and vaporized water alongside copious carbon monoxide, hinting that it may have come from a frigid stellar environment. In the case of 3I Atlas, initial observations suggest it is not made of stone, but is instead mostly comprised of ice, as shown by its misty halo. As Atlas draws nearer to the sun, we expect it to warm up and release gases more vigorously. With luck, this will help us spot particular chemical emissions. Astronomers will search for traces of water, molecules built from carbon, or even more unusual substances like oxygen or organic compounds. It is as if we have received a sample from another star's pantry. Whatever discoveries await, be they familiar or entirely new, will reveal how closely this comet resembles those that formed near our own sun. Could it be made of the same raw materials? Should Atlas prove chemically similar to our local comets, it could mean that the foundations of planets, and perhaps life, are scattered throughout the galaxy. Conversely, if Atlas is markedly different, that would be fascinating in its own right, suggesting it arose in a place with a unique chemical recipe. So why all the excitement? Why are scientists so eager to study a comet that most people will never see with the naked eye? The significance of 3I Atlas is that it is a tangible relic from another solar system, passing astonishingly close to our cosmic neighborhood. Imagine a fragment of an alien world dropping by, freely delivered to our doorstep. Throughout history, we have only examined material from our own solar system: moon rocks, meteorites from Mars, comet dust, and asteroid samples collected by probes. Interstellar visitors like this offer us a rare window into the chemistry and conditions surrounding distant stars, all without launching a spacecraft, a voyage that, with today's technology, would take tens of thousands of years. Atlas stands as a messenger from distant realms, potentially carrying vital clues about the origins of planets or even life itself far beyond our horizon. These objects may harbor hints within their structure, such as unusual isotope ratios, uncommon molecules, or other characteristics that betray their birthplace. There is also the sheer wonder of discovery. Each interstellar object is unlike any other. With only 2 previous cases, every new arrival from beyond our system has the power to transform our understanding. Is this third interstellar object a rare exception, or does it fit a broader pattern? If its chemistry closely matches that of Boral-Solve, we may begin to suspect that many solar systems produce comets much like our own. If it stands apart, that could hint at a more mysterious origin. With 3 samples in hand, we can finally start estimating just how many of these cosmic travelers frequent our solar system. Some researchers propose that thousands of such objects could be passing through at any moment, most simply too dim for us to notice. As our instruments become more powerful, we may start to spot them more and more frequently. In short, we are on the threshold of a new era of exploration. The Vera Rubin Observatory, located in Chile, has already commenced its work this year.
Through its ambitious legacy survey of space and time, the observatory will sweep the heavens each night with extraordinary precision. Specialists anticipate that Rubin may unveil several new interstellar objects within the next 10 years. This suggests that Atlas could merely be the first among many cosmic travelers we will encounter in the coming years. Investigating 3I Atlas holds practical value as well, preparing us for what lies ahead. Organizations such as the National Aeronautics and Space Administration and the European Space Agency seek out these objects, not only for their scientific intrigue, but also because of the unique challenges they may present. These visitors hurtle through space at great speed and are often noticed only at the last moment. Imagine if, someday, an interstellar object were detected on a direct path toward our planet. To assess whether it represents a danger or a unique opportunity, we must understand its behavior and makeup. Moreover, new missions are being conceptualized to intercept or rendezvous with such phenomena. The European Space Agency's Comet Interceptor, planned for launch in 2029, is one such example. This spacecraft will linger in space, awaiting an ideal target, perhaps a pristine comet from the Oort cloud, or maybe even another interstellar wanderer, and will then rush to meet it. The purpose is to be ready in advance, so we do not have to hastily build an expedition from the ground up if a surprise visitor appears. If a probe had already been available, imagine the wealth of knowledge we could have gained by skimming past this third interstellar object, gathering its dust and gases firsthand. With future advancements, this vision may soon become reality. For 3I Atlas itself, there is no mission planned at the moment. Its discovery occurred only a few months before it drew near, far too late for a spacecraft to catch up. It will depart as swiftly as it arrived, yet the insights we gain today will lay the groundwork for future endeavors. Perhaps, for the next interstellar guest, we will detect it years before its closest approach, offering enough lead time to arrange a meeting. As researchers emphasize, even our most rapid rockets would need tens of thousands of years to reach the nearest star. Objects like this briefly bridge that immense gap, a rare chance we must not squander. Should we fear 3I Atlas? Absolutely not. Instead, we should be awestruck by its presence. It serves as a vivid reminder that the universe is not isolated. Matter, and perhaps even the precursors to life, can voyage from one star to another. At this very moment, astronomers everywhere are directing their telescopes toward this third interstellar visitor. Both renowned observatories and dedicated amateur stargazers are capturing its image on clear nights. They record its brightness, monitor the extension of its tail, and refine its trajectory with every new measurement. Through September of 2025, the comet will be ideally situated for viewing from the nighttime side of Earth. Around October, however, it will drift too near the sun from our perspective, becoming invisible due to the sun's glare. By late October, as it reaches perihelion, its closest approach to the sun, the comet will be aligned with the sun from our vantage point, lost in daylight. Yet, by early December 2025, when 3I Atlas begins its exit from our solar neighborhood, it will emerge once more in the night sky. We will have a final fleeting window to study it as it retreats into the cosmic abyss. Scientists realize that it may be many decades, or even longer, before we witness another event quite like this. Although a traveler from a distant star system will soon be gone, the discoveries we make will endure, guiding us ever closer to comprehending our place in a universe teeming with wanderers.